One of the universe's greatest mysteries is the void of Boötes. The most barren region in the known cosmos is called the Great Void, sometimes known as the Boötes Void. Since it is so vast and oddly empty, this part of the cosmos baffles astronomers. What takes place here, and how did it come to be? Let's investigate. The night sky appears to be a rather homogeneous space when we stare at it, am I right? Nevertheless, that is in no way true. There is a vast, spherical region called the Boötes Void, which is estimated to have a diameter of 250 million light-years and contains only around 60 galaxies. From a practical standpoint, and when taking into account the size of the universe, this region is essentially empty. Black holes and voids are not the same thing. Black holes are enormous celestial things that are created when a star dies. They have the strongest gravitational pull and are the universe's densest objects. On the other hand, voids are exactly that regions of the universe that appear to be completely devoid of all life. A mysteriously empty space. About 700 million light-years from Earth, and thusly named after the constellation of Boötes, the Boötes vacuum was found in 1981 by astronomers Robert Kirshner, Paul Schechter, Augustus Ulmer Jr., and Stephen Scheckmanen of the University of Michigan, United States. This enigmatic cosmic place was discovered by researchers while they were looking at galaxy redshifts. Galaxies can be measured by their redshift to determine their distance. The Doppler effect, which alters the apparent frequency of waves when the emitter moves, causes a redshift when a light source moves away from an observer and a blueshift when it moves toward them. A galaxy goes away if it has a redshift, but closer if it has a blueshift, according to astronomical spectroscopy, which employs the redshifts of the Doppler effect to calculate the motion of far-off celestial objects. The redshift can be used to determine how far away a galaxy is because, as our universe expands, it moves more quickly the further it is from us. This was used by Kirshner and his team to produce a 3D universe map. They then spotted a peculiar phenomenon, a blank space where there ought to be thousands of galaxies. It was initially referred to as the Big Nothing, but it soon turned out to contain a few tiny galaxies. Not as empty, the Boötes Void, despite its name, is not void. We immediately turned our telescopes at this enigmatic location when scientists found it in order to thoroughly investigate it and solve all of its puzzles. They made the initial discovery that it included galaxies, but these galaxies were distinct from the ones we are familiar with. Galaxy clusters can be thousands or even millions of light-years away in the universe, but the galaxies in the Boötes vacuum were all by themselves. Like galaxies orbiting the Milky Way, galaxies tend to cluster or be close to one another at the void's boundaries. It is exceedingly unusual that just roughly 60 galaxies have been found in the immense region surrounding the Boötes Void, when there should be at least 2,000 galaxies in a location-like size. These discoveries sparked fresh inquiries into voids, such as the reason behind galaxies' isolation from their surroundings. Conversely, why do certain galaxies gravitate toward voids while others do not? It's a puzzle. The Boötes Void is how big? Although it only has a few dozen scattered galaxies in the shape of a rough tube that flows directly through the center, this region has a diameter of 250 million light-years. Its size is equivalent to 2% of the observable universe's diameter. To illustrate this point, consider that even once our Milky Way galaxy and the Andromeda galaxy were to fit inside the emptiness, there would still be plenty of room. This region is frequently referred to as a supervoid because of its vastness and since it was one of the first huge voids to be found. The Boötes Void is currently recognized as the universe's loneliest place. Even if it has up to 60 galaxies, this is little when you consider that most of them are minuscule and that an area of the universe with such dimensions should have thousands of galaxies. It appears that galaxies have left this area for an as yet unknown reason. Origin. A view of cosmic space reveals a network and filament structure made up of both ordinary matter and dark matter. The latter makes up an enormous 80% and interacts with ordinary stuff gravitationally. Astronomers can spot it in this way. Yet, in between these filaments and spirals, there exist cosmic voids that are extremely thin and vary in size. Its traits are nonetheless constant. A nest-like structure can be created by a void leading to another void within it. According to experts, these empty bubbles hold the answers to some of the universe's mysteries, including the nature of dark matter and dark energy, which drive the universe's expansion to accelerate. The vast Boötes void might have developed from the union of lesser voids. According to one theory, this explanation is because galaxies appeared gathered in tubular form as if they had been grouped relatively recently. Scientists are intrigued by the Boötes vacuum since it is unclear how it developed or how it will change in the near future, given that it appears that galaxies are veering away from it. The universe's creation is another factor contributing to this emptiness. All of the universe's matter was extremely compact in the early universe. It was initially believed to be a uniform soup, but shortly, minor variations in the distribution of matter were produced by random quantum fluctuations. As certain regions became slightly denser, their gravitational pull increased, drawing matter away from less dense regions. They became even denser as a result, which increased their gravitational attraction once more and caused them to drag in additional stuff. Due to the universe's rapid expansion at the same time, these quantum-level oscillations eventually covered hundreds of millions of light-years. Smaller masses of matter started to coalesce into galaxies in the meanwhile. Astronomers can acquire an insight into the early universe's appearance by analyzing these massive structures. Kirshner's maps may now be made in greater detail thanks to advancements in imaging technology and telescopes, such as those made by the Dark Energy Survey, which surveyed a fourth of the southern sky and looked at roughly 300 million galaxies. Supercomputers can now produce in-depth simulations of how the universe evolved from those early Big Bang moments to the universe we see today. Astronomers are able to comprehend how our universe evolved by contrasting these maps with simulations. Voids filled with dark energy. As close to nothingness as we could locate, the voids are huge regions of the universe devoid of galaxies, stars, cosmic dust, or asteroids. The voids, despite what their name suggests, are not empty since, in addition to the galaxies we have just covered, they are also brimming with dark energy. In the event that dark energy were to exist, it would exert pressure on the cosmos that would tend to speed up its expansion and produce an attractive gravitational force. The most systematic method to explain recent discoveries that the universe appears to be expanding quickly since 6145 million years is to take the presence of dark energy into consideration. The explanation for this would be that while dark energy's density increases with expansion, the density of matter decreases. Despite being completely undetectable, dark energy is necessary to explain the standard model of cosmology, in which it accounts for over 69% of the total energy of the observable universe. Because that dark energy is known to permeate the whole cosmos, regardless of whether there is matter present, it follows that this unobservable energy must also be present in the enormous Boötes void. If the matter slows the growth of voids, the dark energy makes them grow, which means that the voids will continue to grow over time thanks to the force provided by all the dark energy. This mysterious energy, which has no interaction with matter but is present throughout the universe, may be what allows the existence of voids. Do more void exist? No doubt. It is not the only vacuum. There are others as well, such as the Eridanus supervacuum or cold point CMB, which is significantly larger and has a diameter of around 500 million light-years. The Boötes vacuum is better known, despite being one of the most significant structures in the universe. Another poorly populated area of around 150 million light-years is the local void. The edge of this void is not too far from where our galaxy is located. It is estimated that the local void center is at least 75 million light-years away from Earth. Do you believe that the cosmos will continue to include voids in the future? Thanks for watching, and share your thoughts with us in a thoughtful remarks.